right, welcome to another edition of Let's Review. Okay, I'm going to go over the review for the derivatives for calc, and let me know if you have any questions. This will be posted on Wednesday, and today's date is April 22nd, and I will have a live session tomorrow to go over any questions you might have. I'll be posting a final review on Friday for antiderivatives and integrals. And then next week we start practicing some AP test questions in preparation for the test and to help reviewing our topics. After May 12th, the test is done, and we will go and visit some more topics that would be nice to know before you guys head off to either college or until next year. So let's get started. All right. Now, I notice how I say here, I don't mind if you simplify them, and that's true. But what I'm going to do is I am going to just give you some basic tips for simplification in case it calls for it. All right, so it's it's a quotient rule. So it's the bottom times the derivative of the top. Derivative of 2 is 0. Derivative of cosine is negative sign, so it's 2 negatives make a positive, minus the top times the derivative of the bottom. The derivative of sine is cosine, just cosine. I almost said cosine squared. Over the bottom squared, which is sine of x squared. So sine squared of x. So you could say in its most basic form, this is the correct derivative. You have accomplished the derivative with quotient rule. However, there's some easy steps to take to make this look nicer. Sine times sine is sine squared. Minus 2 minus, a negative cosine times a positive cosine is a negative cosine squared. So that negative makes it positive cosine squared all over sine squared. Now there's a quick little easy thing you can do to make this look nicer. Do you remember, I don't know if we talked about it much ourselves, and I don't know if you went over it earlier in the year, but I know you did this last year in pre-calc. Remember that identity, that sine squared plus cosine squared equals 1? Well, don't we have a sine squared plus cosine squared right up here? We do. So that means that sine squared plus cosine squared is 1 minus 2. And 1 minus 2 happens to equal negative 1. So all that really boils down to this. Do you need to simplify it that far? Typically not, but it also depends on the situation. If you need to solve something, it might be easier to simplify it before you plug it in. If not, it's up to you. It is a question based upon your needs more than anything. Okay, that is number 1. Number 2, use the graph to determine all x values which the function is not differentiable. Now, sure, there's 2 you can pick off right off the bat. Whoops. First of all, right here at a. So it's not differentiable at x equals a. Okay, these are the not differentiable points. Remember, differentiable means you just can't take the derivative. Now, why can't you take it at a? Well, because it comes to a point. Basically, the slope changes from negative to positive instantaneously, and you're not allowed to do that. So x equals a because it's a sudden change of slope. Really an instant change of slope, which looks like a point on a graph. Oh, I just put point. I meant to say sudden change of slope. All right. This looks good, this looks good, this looks good, and now at f. Well, it can't be at f because, frankly, there's a gap. It's not continuous. So that's a problem. If there's a gap, if it's not continuous, there is no answer. There is no slope at that point. And you might not recognize this. It doesn't happen often. But right here at point G, if you can kind of imagine. See how it kind of goes straight vertical for an instant before it comes down. It's like an inflection point. Now, inflection points don't always have this type of sharp increase, but technically, right here at this point, the slope is undefined. That one moment. Okay. So the slope is undefined. We actually call that an infinite slope at that point. Now, if you haven't recognized that, it's not a big deal. You probably didn't talk about it, and it's a unique case. It doesn't happen very often. But as long as you know about the points and the gaps, you're all set. Okay. All right. Now, so some flat out derivatives. So remember, and I know you know what this means, but I always feel it's nicer to see it that way. I know it takes longer to write, and that's our shortcut for it. But anyway, so if you take the first derivative, it's 4 times this whole thing to the, why did I put 4? Wow. It's 3 times this whole thing to the second powered times the derivative of sine, which is cosine of 4x, but yet we have another one thrown in there. We have another function of 4x, and its derivative is 4. So when this is all said and done, you're going to get 12 sine squared of 4x times the cosine of 4x, and that's your derivative. Okay? Nothing much to do to simplify it. That's just the way it is. All right, number 4. So find the slope, or find the derivative, I'm sorry. Now, this is an implicit differentiation question, which means we have y's and x's thrown in together. So, one at a time. We'll start with y squared. What's the derivative of y squared? Well, it's 2y. But because we're finding the derivative of y with respect to x, then the chain rule says the derivative of y is dy dx. And remember, the shortcut is, if you're finding it with respect to x just takes a derivative like normal. Anything that's not x, like a y, you tack on a dy dx on it. Okay. It's kind of a strange way to think about it. All right, xy. I'm going to take the negative 3 outside because it's a constant. What's the derivative of xy? Well, it's a product rule. It's the first times the derivative of the second. The derivative of y is dy dx plus the derivative of x, which is just 1 technically times dx over dx, but that's 1 because dx is what we're taking the derivative with respect to. So it's 1 times the second. The derivative of x squared is 2x. The derivative of 7 is 0. Now, I said you can simplify, but you really should solve this for dy dx, which really won't be that bad. We just keep all the dy dx's together and then multiply this through. So negative 3x dy dx minus 3y plus 2x equals 0. So we're going to throw all the terms without a dy dx on the other side. So we'll add 3y to both sides and subtract 2x. Then we can factor this dy dx out. And see if I can grab myself a little more room here. Can I write down here? Oh, I can. I didn't even think I could. That's pretty cool. So we're going to factor out a dy dx. Be 2y minus 3x. And we'll simplify and put it over here. We'll divide both sides by the 2y minus 3x. Nothing else you can do. That's the derivative. Implicit differentiation. All right? I thought that might happen. That's okay. You can kind of see what happened here. All right, the derivative of this. Now, to do the derivative of this, there's a couple ways we can do it. Some of you might all of a sudden see quotient rule, but I see this. It's to the 1/3 power. Now, because it's in the denominator, it's actually a negative 1/3 power. So if you can convert to this to this, it makes the derivative a whole lot easier. So the derivative would be negative 1/3, 3 minus x cubed. Now lower that by 1. So negative 1/3 minus 1 becomes negative 4/3. And then chain rule the derivative of what's inside, so negative 3x squared. So again, that's the unsimplified version, and it's fine. Let me just clean it up a bit, because I always feel the need to do that. I don't know why. All right, this negative and this negative are going to cancel out. They're fine. Here's what we got. The 3 is on the bottom. Oh, I missed something else that canceled, but I'll do it later. This 3 minus x cubed, negative 4/3. So, whoops, I wrote that one wrong for sure. So 3 minus x cubed to the 4/3. And what's on top is a 3x squared. You see I forgot the 3's. So really it boils down to x squared over, and let me do it this way because it looks more cool, be the cube root of 3 minus x cubed to the 4th. Okay. All right. There we go. The nice thing is I don't think there's going to be a lot of time or necessity to simplify things on the test this year, since there's no multiple choice. But we will have to be able to use these things if necessary. Okay. And we'll show some examples later on of what I mean by that. All right, the derivative of natural log of all this mess. So remember, the derivative of natural log is 1 over whatever is in there times the derivative of that. Okay, now we got a few things going on. We definitely have a product rule, because we have x squared times either negative 2x. We'll do it that way first. The derivative, product rule goes to the first, the derivative of the second. So it's either negative 2x times the derivative of its exponent, which would be negative 2, okay, plus, and we reverse it, derivative of x squared is 2x times the second. Now the thing is kind of weird. Again, that's your unsimplified version, and that's good. If you got that far, you got the calc down. The rest is algebra. So I'm going to, again, take it a step further because I can. Do you notice that if this is the top of the function, this is the top, this is numerator, this is the denominator. I'm going to take the top. I'm going to factor out either negative 2x. And it leaves me with this. And what do you notice? What's nice about that? Boom, boom, those will cancel out. And what else could we factor? We could cancel something else out if we wanted to. I'll show you. Do you notice that all the terms have an x? So we can take an x out of each one. You could even take it a step further if you wanted to divide them all by x, make it negative 2 plus 1 over x, but you know, why? There's always a limit. How far do we go? How far do we go? How far do we go? The nice thing is when you do these for real, when you do them in an application or a job or on an AP test, you're going to know where you have to go to stop. You just need to get to a spot where it works out nicely. Okay, and a situation, can't speak, be like number 7. Particle moves along a curve, find the acceleration. So remember, the acceleration is the second derivative of position. So I'm going to write this way. Now, the first derivative is not going to be too bad. Second derivative, you're going to go, oh, really? But we don't have to simplify. Once we get it done, we're just going to plug in 2. All right, so y prime is 1/2 of t cubed plus 1 to the negative 1/2 times 3t squared. All right? But now we need the second derivative. Yeah, so you see now we got a product rule on top of this thing. What I'm going to do, just to get it out of my way, the 3 and the 1/2, they're constants, so they really don't affect anything until the end, so we can pull them both out. So what I'm going to do, and I'll just rewrite this so you can kind of see what I'm doing here. I'm going to rewrite this as t cubed plus 1 to the negative 1/2 times t squared. So I pull out the 3 basically. Here we go. Now the second derivative. It's going to require a product rule with one of these. So the 3/2, again, is a constant. It's going to stay. So here we go. It's going to be the first function times the derivative of the second function. The derivative of t squared is 2t plus, now we're going to reverse it, the derivative of the first function. So we're going to pull the 1/2 out. The t cubed plus 1 stays there. We're going to subtract that by 1. So negative 1/2 minus 1 is negative 3/2 times the derivative of what's inside, which is 3t squared. Okay, you see I'm kind of writing small now so I can fit this in. Times the second function, which is t squared. And we squeezed it in. Ugly, isn't it? But you don't have to bother simplifying it, because now we're just going to plug in the number of 2 and see if we end up with something nice. So I'm going to do each part separately. So I'm going to do this part first. Alright, so just this part. When I plug in 2, I get 2 cubed, which is 8. 8 plus 1, which is 9. 9 to the 1/2 is 3. But the negative makes it 1/3. Okay? I'm going to plug in 2. 2 times 2 is 4. Alright, now this one. It's going to be a biggie. Follow along. 2. 2 cubed is 8. 8 plus 1 is 9. 9 to the negative 3/2. Okay? So 9, the square root of 9 is 3. 3 to the third is 27. The negative makes it 1/27. So this is negative 1/2, and t cubed plus 1 to the negative 3/2 becomes 1/27. If you're not sure, put it in your calculator. The nice thing is you get to use your calculator for the test. All right, 3t squared. So I'm going to put in t is 2. 2 squared is 4. 4 times 3 is 12. And lastly, t squared, which is 4. So this monstrosity is our answer. I don't know why I'm not using a calculator. I guess I enjoy pain. I'm sure you guys have already jumped your calculator, which is fine. Let's see. All right, I'm going to. Sorry. Okay. 12 times 4 is 48. So I'm going to get 48 over 54. I knew it would have simplified. And I'm just going to put that in my calculator now. Wow. It all comes out to be 2/3. Oof. That was a lot of work. That was a lot of work. And you can see by how much work that was, You're probably not going to be asked to do things as complicated as that on the AP test because there's no time. But it's good to understand how that worked out. Okay, and that's an example where you don't have to, when you're up here, you don't have to simplify it. Just keep it ugly, plop in the 2 and go. Now you're going to see there's a lot of calculation there. So the other nice thing about the AP test is you're not going to worry about calculation too much because they're not going to require a calculator since everybody can't have one. So you're okay. I'm going to change color now for a little bit. Equation of the tangent line. Remember, a tangent line is just a line. When you have a line, you need 2 things. You need a slope and a point. That's all that you need. Now, there's a formula for tangent lines, but I don't even care about the formula because it's just a line. Let's find the point first. We're looking at x equals 1. So what is f of 1? 2 minus 2, which is 0, plus 3. Our point is 1, 3. Now we just need our slope. And we find the slope by taking the derivative. 4x minus 2. So the slope at 1 is 4 times 1 is 4. 4 minus 2 is 2. So I know these 2 things right here. And now we just go back to algebra. Algebra 1 even earlier. Just find an equation of a line. I don't care if you use y equals mx plus b. I don't care if you use point slope form. I will use point slope form because that's the one I prefer. I'm just going to plug in numbers. The y value is 3. Oh, geez, I can't even write. The slope is 2. And the x value is 1. And now I'm just going to solve it for y. 2 times 1, I'll distribute the 2 of course. Add 3 to both sides. So my tangent line equation is 2x plus 1. Point and a slope. That's all you need. So don't let those tangent lines get to you. Point and a slope. That's all you need. All right. Instantaneous rate of change. Well, what does that mean? Derivative. That just means find the derivative. All right. So find the rate of change of w with respect to z. So basically we're looking for this. Z is our only other variable, so you can think of it as w prime. All right, so let's do this. Let me change w itself. I'm going to make that z to the negative 1 and 1/2 is z. Just easier for me to visualize it. So the derivative would be negative z to the negative 2 plus 1/2. That's it. Maybe one little thing to make it a little different looking would be put it back over z squared. There you go. Just like that. Nothing too crazy. Just taking the derivative. All right. Now I don't mind if you don't remember the formula for it, and that's okay. Because I remember I'm going to take you back through something you need to know or remember for this problem, but you're not going to be required to know it on the AP test because they give you any information that you would need. They're not trying to test your physics ability or your memorizational skills necessarily, but how you operate and how you use things. So you probably don't, well, some of you do. Remember acceleration in feet is negative 32 feet per second squared. Okay, so that's the acceleration. If I have acceleration, how do I get to velocity? Well, I take, basically it's antiderivative. What function would give me negative 32 as a derivative? So negative 32t plus some constant. Remember that constant is your initial velocity. Because v of 0 would equal 0 times 32, 0 plus 26. Now be careful. It's being thrown down. So since we used negative for acceleration because it's pulling down, we should say that if initial velocity is negative 26. So this should be negative 26. So our velocity is negative 32t minus 26. Now, we want to know the equation for movement, which is our position. Typically in calc we call it s. I do not know why, but we do. And what function would give this as a derivative? Or what's the antiderivative of this? So remember, take t and raise it by 1, so it's t squared divided by 2. Plus another constant. We'll call it d this time since I don't use the same one. Well, d is your initial position. We're 220 feet up. So our d value is this. So this function right here describes the motion of the object. Now some of you might have remembered the formula, just plug the numbers in. That's great. Remember, on the AP test, they're not going to ask you to have a formula memorized to plug in numbers like that. It's all about how you think about a process. But I thought it'd be good to review this stuff just so you remember how to do it. So question B says, what's the velocity at 1 second? Well, we have our velocity function right here. Just going to plug in 1. Oh, and here's the danger. I'm going to try to do math in my head. Negative 32 minus 26, so we're really adding them together. What is that, 58? So it's negative 58 feet per second, right? Because it's traveling down. And it's faster than its initial velocity because gravity is pulling it down faster. And that's how you would do these problems.